So I bought these lenses here because I was hoping to convey the idea of how the compound microscope works. And it's this set that comes with like 3 different lenses. And plus I love buying like science related stuff. And I pretend it's for my daughter, but it's for me. Anyway, I got it, and you can like switch the handle with these guys, but for now I'm just gonna use the lenses to tell you, okay, there's the largest diameter, the middle, and the small. And the largest diameter actually magnifies less. It's 2.5 times. When we use the ocular of the microscope, it magnifies 10 times. So just the ocular lens already magnifies more than this one. And okay, 5 times and 16 times. So in the microscope, we have these guys, which are 10x, and the reason I know it's 10x, actually, wait, I don't know if it's giving feedback or not. Don't know if it's better for you, but the reason I know that these guys are 10x is because I look at here. Let's see if you can see that. It says like right here. It's like etched in there. Maybe you can see, maybe not. But not every microscope is going to their ocular be 10x, most of them, but it could be 15x. So for you to know what's the total magnification of a sample that you're looking at, you need to see what is the magnification of the ocular, and then you need to see what's the magnification that you're using, which objective. So if you start with your lowest objective, which it says on the side 4x, might be too far to see, but it says 4x there. So it says 4, 10, 40, and 100. So you would have 10x for this, which this is the one that has the ruler. Let's see if you can see the ruler. There you go. Hey, that's the ruler. See that? That's what we're going to use. We're going to learn how to use the ruler to calculate the size of a sample. So let me make that analogy here. I have this guy here. It was, with my little kit, it was a 5x. So that would be like my ocular. And then I have this one is my 2.5x. So that would be my lowest power objective. When I look at this, look at that. I don't know if you guys can see that. Actually, it makes things upside down. And then I do this. All right. And then let's see if it's going to make it better. There we go. So there has to be some light. And then I do this. Now, then you have to like do the correct distance from the object for things to be in focus, which I'm fading right now to do. The microscope is actually easier than what I'm trying to do here. But your total magnification is how many times are you seeing with just this times how many times do you see bigger with just this. So when you do a compound, when you use both of them, then your total magnification is the one and the other. And in math, whenever there's an and, then it's a multiplication. And if you're doing OR, it's plus addition. All right, so if I'm using my 4x objective and my 10x ocular, then what's my total magnification? Let me write this here. 4x objective and 10x ocular. What is the total magnification? And you know what? You may not want to write on the chat, I'm going to share with you a whiteboard, and you may write there, right there, and it's anonymous. So all I know is that you're writing some color. Yeah, good job. 40x, because we do not end. Yeah, good job. All right, so now you know that when you look at a microscope picture, it will have the field of view many times, so like the circle, which is what you see when you're looking at the microscope, and then your slide or your picture should say the total magnification. So in this case, 40x, because of the 4 and the 10. Most times when you see pictures of things from the microscope, people zoom in more. So the 4x is more used just to find your sample. Then once you find it, then you look closer. But this is just an example. And then the other thing that you would see is like a little line. And it would say, this measures, let's say that this line is 10 micrometers. So this is your size standard. Pretty much like when you look at a map, and then there is like a thing underneath saying this many kilometers or this many miles, for you to have some idea of the magnitude of that distance or of the size of your sample. In exam, when I ask you which one of these is a good microscope slide, and they have to have the total magnification, the size standard, and then some drawing here. And it could even be my drawing. I cannot draw to save my life, so let me just show it to you. In the lab, my favorite thing to look at is this thing called the sea monkey, and I cannot draw it at all. But, okay. So this one would be a perfect microscope picture, even though I'm very limited in my artistic abilities. What it has is something that I'm looking at, the total magnification, and the size standard. So now you're like, how do you know that this is 10 micrometers? And I'll go like, oh, I'm glad you asked. So that's the part that I'm going to address now.